In this lecture here, we want to talk about how you solve polynomial and rational inequalities. So now this lecture here only has two objectives. So the first is we want to solve these polynomial inequalities. So that's going to be lecture number 1. That's going to be this first video. And then I'm going to follow it up with a second video on how you solve rational inequalities. So this will be lecture number 2. Okay, so we'll start with polynomial inequalities here. So what exactly is a polynomial inequality? So a polynomial inequality is any inequality that can be put in one of these forms. So we have some function f of x, okay? And so f of x is going to be some polynomial function. So actually, like the first one we'll work with will look like this: x squared minus x minus 20. Okay, so that's a polynomial function. So here it is. What we want to do is we want to solve this inequality. So we want to find the values of x for which f of x is either less than 0, when it's greater than 0, less than or equal to 0, and greater than or equal to 0. And so what makes this really, really difficult is there can be more than one solution that does this, right? And oftentimes for these problems, there's going to be an infinite number of solutions that satisfy these inequalities. So how are we going to solve these, right? So I'm going to show you how you find the intervals for which satisfy these polynomial inequalities. And so what you're going to notice here is I'm going to put up a process for this, okay? A number of steps for this. And they're not going to make a ton of sense the first time I go through them, but I promise you, as we do these problems, as you see the examples, they will absolutely make sense. And it'll become like, okay, I get what's going on here. I get what's going on here. Okay. So here's the procedure for solving polynomial inequalities. So the first thing you're going to do is you're going to express the equality in the form of f of x is less than 0 or f of x is greater than 0. So, and this is again where f is some polynomial function. So really what you want to do is you want to set one side of the equation. So one side to be 0. Okay, so if you have some constant terms or whatever, you just need to move it around so that you have one side is 0. Next, what you're going to do is you're going to set this equation, okay? So you're going to solve the equation f of x is equal to 0. Okay, so we know how to do that. This will be a piece of cake to solve those. But so what's going to happen is the real solutions to that equation are what are called boundary points. And these boundary points are very important. Okay, they're literally the key to solving this. All right, so then what you're going to do is you're going to locate the boundary points on a number line, thereby dividing the number line into intervals, okay? And these intervals, okay, these intervals, there's going to be more than one interval in these problems here, okay? But of the intervals, these are going to be your solutions, okay? So your solution will come from these intervals. Okay, so now next thing you have to ask is, well, like what intervals, how will I know which interval is a solution? And that's where the next step comes in. So what you're going to do is you're going to choose one representative number called a test value within each interval and evaluate f at that number. Okay, and these test values are a single test value would tell us the sign of all the values in that interval. So if the value of f is positive, then f of x is greater than 0 for all numbers x in that interval. And if the value of f is negative, then f of x is less than 0 for all numbers x in that interval. Okay, so this part here seems really confusing, step 4, but I promise you I'm going to work through 3 examples of this, and after you see a few examples, you'll be like, oh, okay, this is making sense. And then what you're going to do is you're going to write the solution set, selecting the interval or intervals that satisfy the given inequality. And I will show you how to do this. Okay, it's very, very straightforward. All right, this procedure is valid if if less than is replaced by less than equal or greater than is replaced by greater than equal. However, if the inequality involves a less than or equal to or a greater than or equal to, you include the boundary points, okay? So those solutions to that f of x is equal to 0 in the solution set. So what I'm going to do for you here is you'll see that I'm going to do three examples. So the first one will be a strict inequality, and then the other one will be less than or greater than. I'll do a less than equal to, and I'll do a greater than equal to. Okay, so here's the first problem we want to solve, okay? So let's solve this. let's look at x squared minus x is greater than 20. All right, so I want to solve this. Okay, so the first thing you're going to do, all right, notice how this is not set to 0. Okay, so step 1, make one side equal to 0. So what I'm going to do is I'm going to take this 20, I'm going to subtract it over to the other side. So when I do that, I'm left with this right here. All right, so what's going to happen here is this is going to be my f of x. Okay, so now step 2, you're going to solve equation as if it was equal to 0. So I'm going to take x squared minus x minus 20. It's going to be equal to 0. So I can solve this by factoring, right? So two numbers that multiply to negative 20, sum to negative 1, are x minus 5, x plus 4 is equal to 0. And you can see here that I get two solutions, right? So either x minus 5 is equal to 0, or x plus 4 is equal to 0. So one solution is x is equal to 5, and another solution is x is equal to negative 4. Okay, so going back, these right here, these are our boundary points. Okay, boundary points. All right, so our boundary points, I'm going to put them in order, are x is equal to negative 4 and x is equal to 5. All right, so what you're going to do next in step 3 is you're going to carve up a number line like an interval. So going back, what you do here is you're going to locate the boundary points on that number line, as I said, thereby dividing the number line into intervals. All right, so you're going to have this number line with boundary points. All right, so here's what's happening. Here's a number line. And my boundary points were this. They were the numbers going back. It was negative 4 and positive 5, okay? And so I know I wrote it a little bit weird there, but so what's going on is, okay, so this over here, this side of the number line is one interval. So it's all the numbers from negative infinity to negative 4. Then in between is another interval, negative 4 to 5. And then after 5 is another interval, 5 to infinity. So look, I have 3 intervals here, which means my solution, okay, my solution to this, going back, x squared minus x is greater than 20, it's going to have to come from one of these intervals. So in step 4, what you're going to do is you're going to pick test values within each interval. All right, so just so we're clear, going back, my f of x here was x squared minus x minus 20, okay, because that's what was right here, okay, x squared, if it helps to see it. All right, so what I do for this step 4 here is I kind of set up a table. So look, I write what are the intervals that could be my solution. It could be negative infinity to negative 4. It could be negative 4 to 5. And then it could be 5 to infinity. And then what you do next is you pick a test value. Okay? So pick any number between negative infinity and negative 4. We'll make it easy on yourself. I'll pick negative 5. Pick a number between negative 4 and 5. I'll pick 0. Pick a number between 5 and infinity. I'll pick 6. So then what you do is you take this and you evaluate f of x at the test interval. So at the test value. So look, you're going to figure out what f of negative 5 is, right? So if you were to take negative 5 in here, right, so you get negative 5 squared minus 5 minus 20. Okay, so think about what this is, right? So this is 25, and then minus becomes plus. So this is 25 plus 5 is 30, minus 20 is 10. Okay, so what this means is that all values, all numbers between negative infinity and 4, when you plug it into f of x, are positive. So I'm going to put a little plus sign here. F of 0, if you plug 0 in this, you just get negative 20. So that means all numbers between negative 4 and 5 are going to make the function be negative. Okay? And then when you plug in f of 6, right, well, this is 36 minus 6 is 30, minus 20, that just gets you 10. So look, what I'm saying here is the function will always be positive. It will always be greater than 0 between negative infinity and 4. And this will also always be positive for all numbers between 5 and infinity. Okay, so now step 5, your last step here. Write the solution set selecting the interval or intervals that satisfy the given inequality. So here's what I was looking for. I was looking to be greater than 0. Greater than 0. After I move the 20 over, I'm looking for values that are greater than 0. So I'm looking for positive intervals. So step 5, solutions. Well, I could have from negative infinity to negative 4 satisfies, and then also, so I'm going to union it with 5 to infinity. That also satisfies. So you can also draw this on a number line, right? Like here's 0, here's negative. This is not drawn to scale. Negative 5, and it's going to be all numbers this way and all numbers this way satisfy the equation. Okay, so just to recap, the key is to find these boundary points by solving the equation set equal to 0. And then what you're going to do is you're going to pick test values in the interval, look at the sign, and then figure out how that satisfies the inequality. All right, let's do another one. So this was just our first example. So this was example 1. All right, so here will be example 2. I'll do a little bit easier one. And then I'll follow it up with a really hard one. So let's solve this. Let's solve 3x squared minus 5x is less than or equal to 0. Okay, so step 1 is already done for you. It's checked, it's already set equal to 0. So we just know that our function here is this 3x squared minus 5x. So step 2, you're going to set f of x equal to 0 and solve. So you're going to take 3x squared minus 5x equal to 0. So you can solve this obviously by factoring, right? Just factor out an x. So you have two solutions, right? Either x is equal to 0 or 3x minus 5 is equal to 0. So add the 5 over, divide by 3. This solution is 5/3, right? So this means, you could write this as 1 2/3, just so you can kind of, help you see this, right? But the boundary values, the boundary points here are going to be x is equal to 0 and x is equal to 5/3. And so what you're going to do again, just like I did before, is you're going to use your boundary points, and you're going to carve up the number line, okay? And then you're going to use that to find intervals and then pick test values of those intervals. So step 3, the number line, okay? So our solutions were 0 and then 5/3, which means, again, we have 3 intervals here, right? We have negative infinity to 0, we have 0 to 5/3, and then we have 5/3 to infinity. And going back, notice how this is a less than or equal to. So I'm going to talk about in the end how you handle this when you go to show your solutions, okay? So step 4 here, you're going to need your test values. So set up my table, right? Set up the table that I did. I had the intervals. So negative infinity to 0. 0 to 5/3, and then 5/3 to infinity. You're going to pick a test value. So just like make it easy on yourself, right? So here I'm going to pick -1, here I'll pick 1, and in this interval here I'll pick 2. So just to recall, so our function, our f of x here was 3x squared minus 5x. So now you're going to evaluate f of x for the test value. So f of -1, right? If you plug -1 into this, you're going to end up getting 3 plus 5, so this is 8. So this is positive. If you end up plugging 1 into this, you end up just getting 3 minus 5, so this is -2. So this is negative in this interval. And then, you know, f of 2 here, right? 2 squared is 4 times 3 is 12 minus 10. That gets you 2. So that means it's positive. So now your step 5, your solution. So look, going back, you want it to be less than or equal to 0. So you want it to be less than or equal to 0. So you want negative values. So it's going to be this interval here. But just recall, you had a less than or equal to sign. So what that means is you would take this interval and include the endpoints of the interval. So the actual solution would be closed bracket 0 to 5/3. And so on a number line, you would show it like this. You would have closed bracket, and it would be everything in between here. So when you have that inequality that has the equal sign under it, that means is to include the endpoints. Okay, include the endpoints. All right, let's do a much harder one that's going to involve a little bit of an extra step. Okay. All right, so this was our second example, so this will be example number 3. Let's solve this. Let's solve 4x squared plus 2x is greater than or equal to 1. Okay, so step 1, you're going to have to move the 1 over. Okay, so you end up getting 4x squared plus 2x minus 1 is greater than or equal to 0. So that means the function that we're working with here is 4x squared plus 2x minus 1. All right, so now step 2. You have to solve this. So you set this just equal to 0 and solve. Okay, so here's the thing. This doesn't factor. Okay, so what you have to know, so this is the extra step that makes this hard. So you still have to solve this. So the way you're going to solve this is with the quadratic equation. Okay, so you're going to need to solve with quadratic formula. So x is equal to negative b, so it's -2 plus or minus the square root of b squared, which is 2 squared minus 4 times a, which is 4, times c, which is minus 1, all over 2a, over 2 times 4. So this is -2 plus or minus, this ends up being 4 plus 16, because the negative becomes a positive, over 8. So this becomes -2 plus or minus the square root of 20 over 8. Well, 20 you can break up as 5 times 4, So the 4 comes out as a 2. And then you can see, you know, you can factor out a 2 and cancel, so you ended up just left with -1 plus or minus the square root of 5 over 4. Woo! Okay, so what that means, that was the extra harder part. So what that means then is your boundary, going back here, you know, what we're always looking for is these boundary points here, okay? Boundary points, find the boundary points, So with the quadratic formula here, you have 2 solutions. So your boundary points, one is -1 minus the square root of 5 over 4. And just to save a little time, this is roughly -0.8. I'm just doing that so to help us see here the intervals. And then one is -1 plus the square root of 5 over 4. And this ends up being roughly 0.3. Okay. So now, even though you've got these crazy values here, you still set them up on a number line here. So step 3, the number line. So one was -1 minus the square root of 5 over 4. And then the other value was -1 plus the square root of 5 over 4. And just so to help see, right, this is roughly -0.3 and this is 0.8. So then step 4 here, okay, you're going to need your test values. So set up your intervals, right? You're going to need -infinity to -1 minus the square root of 5 over 4. Your next interval is -1 minus the square root of 5 over 4 to -1 plus the square root of 5 over 4. And then your last interval is -1 plus the square root of 5 over 4 to infinity. So you're going to pick some test values, right? So make it easy on yourself here. So, but you know, this is -0.3, so I'm going to pick -1. In here, I'm going to pick 0. And in here, I'm going to pick 1. So our function f of x, just so we're clear, I'll rewrite it again, was 4x squared minus 2x, plus 2x. Make sure I got that right. Yep, plus 2x minus 1. So evaluate test values into f of x. So I'll just save a little bit of time here. If you plug in f of -1, you'll get 1. F of 0, obviously you get -1. And then f of 1 here gets you 5. So going back then, I want it to be greater than or equal to 0. So I'm looking where the test values are positive. So it's here and here. So this interval is negative. So that means there's 2 solutions here. So step 5, solution. I'm just going to show this one an interval. Okay, so now this is important because it has the less than, it has the equal sign under. That means when you select the interval, you include the boundary points. So it's going to be -infinity to -1 minus the square root of 5 over 4, closed interval, union, closed bracket, -1 plus the square root of 5 over 4 to infinity. Infinity always gets the open bracket. So going up here on the number line, that means our solutions are everything this way and everything this way. So you can see here the key is finding the boundary points, setting up the intervals, evaluating for the test values, and then going from there. All right, class, I'll follow this up with a video on solving rational inequalities next.